if you want to be good at Python, you have to be really good at some packages. One such package is Numpy. If you are really good at Numpy, especially in data handling, in machine learning, or any other Python related tasks which are related to data science, you will be really confident and comfortable. Let us understand Numpy. There is a hell lot of list of contents that we are going to cover in Numpy, so that we are very comfortable with all the operations related to arrays. So NumPy stands for numerical Python. It helps us to create arrays. Obviously, when you are working with data sets, when you are working with mathematical calculations, when you are working with scientific calculations, you need to work with arrays or vectors or matrices, one-dimensional array, two-dimensional array, multiplication, and different logical operations, shape manipulation, sorting, selecting, etc. NumPy is the foundation on which higher level scientific tools or higher level mathematical tools are built on. Let's say if you think of a package called scikit-learn. Scikit-learn is a package that's a machine learning related package. Internally, scikit-learn uses NumPy very heavily. So let us understand NumPy. Usually NumPy is used for creating, manipulating, and working with arrays. First of all, what is an array? How do you define an array? First of all, what is an array? Array is a collection of homogeneous elements. Array is a collection of homogeneous elements. Few elements selected together or collected together is an array. Let us see how to create an array, which function is used to create an array. So here is a way to create array. First, let us open a Google Colab file. In this Colab file, let us write the session name. NumPy is the one that we want, or NumPy, that should be fine. So import NumPy as NP. Let me make this slightly bigger so that you can read this clearly. Import NumPy as NP. And then let me create an array. Let's say I want to create an array income. Income is the array. Let me do that in an Excel. So import NumPy as an array, adding a couple of code cells, and then income is equal to np dot array. In that, I'm defining a list of values. How do you define an array? Use numpy dot array. In that, you define a list of values. So here I'm saying $1,200 is the first person income, and then $1,300, and then $1,400, and then $1,800, and then $1,700, and then $1,500. These are the income values. This is the array that I am creating. Income equal to np dot array, and in that I have to create a list of values. Okay, I'm giving a list of values. So here is the list. We, we have created income array. How do you know this is an array or not? By the way, we have created using numpy dot array, np dot array. Definitely this will be an array. If you want to check a particular variable or particular object like this income, what type of variable is it? If you type, then you will get to know np dot n dimensional array. This is, by the way, one dimensional array. You have 2-dimension, 3-dimension, 4-dimensional arrays also. Those are coming up in our section later on sections. How do you print the array? You can say print income array. That will be printed. This is the array that is printed. Look at this. This array looks similar to a list, but arrays are not same as a list. I'm going to tell you the difference in some time. Array looks similar to a list, but arrays are very different from lists. There's a huge difference. Monumental differences are there. I'm going to tell you what are the major differences between arrays and lists. You can access the array values using indices. By the way, are you typing along with me? Go ahead, type along with me. So you can access array values by using indices. Income 0, if you write like that, then you will get the first value 1200. If I say income 1, then I'll get the second element of the array, which is like 1300, like that. You can access the values using indices. Once you have the array, which is income array, You can create another array by using some mathematical operations. For example, you have income array and you want to create expenses array. Let's say income into some 0.653, 65.3% of income is expenses. Expenses array is created. If you want to print that expenses array, you can use print function or directly also you can print it. Here is the expenses array. This is the income array and this is the expenses array. 0.653 times whatever is given here. 65.3 is the expenses. Now, if you have two arrays of same length, income and expenses, you can create another array. Let's say savings is another array, that is income. What is savings? Income array minus expenses array. Income and expenses. Expenses array. Income minus expenses array will give you savings. And how do you print savings? You just simply say savings array results are here. Remember, this is an array, this is not a list. In the last session, we discussed what is a list, but list is not same as an array. Lists are very, very different from arrays. What is the major difference between a list and an array? First, let me define a list and let me tell you what is the major difference between list and array using one example. So let us take this side heading like list versus array. Let me define two lists. List 1 is equal to a list of three elements, or three elements, 1, 2, 3. And let me define list 2. List 2 is a list of another three elements. Let's say that is 4, 5, and 6. These are the two lists that I have defined and I'm executing them. Let me define two arrays in the same manner. Let's say this is array 1. By the way, how do you define arrays? np.array is the function that you have to use to create this. Okay, this is array 1. And in the similar manner, using np.array, you will create array 2. This is array 2, np.array this. Now I have two lists with me, I have two arrays with me. What happens if I do array 1 plus array 2? This is array 1 and array 2. When you add two arrays, what is the result? It's another array, corresponding elements are added. 4 plus 1, 5, 2 plus 5, 7, 3 plus 6, 9. But that is not true with lists. Lists are not meant for mathematical operations. This list is a simple collection of three elements. List 2 is a collection of three elements. If you do list 1 plus list 2, list 1 plus list 2, it's not going to add the corresponding elements. This is a collection of three elements. This is a collection of three elements. List 1 plus list 2 will be a collection of 6 elements. That's the major difference. List is not meant for mathematical operations. List is not same as an array. List is different from array. Array 1 plus array 2 is a third array. List 1 plus list 2 is a third list. But this array is addition of corresponding elements. This list is collection. It's kind of union of all the elements that you have. That is the first difference. Have you understood the difference? List is different from array. And remember, two arrays can be added. Two lists is just a simple collection. That's the first difference. The second difference is list can contain heterogeneous elements. Let's say if I'm defining my list 3, okay. If I'm defining my list 3, which is 4, and then A, and then 6, okay. Whereas array cannot be like this. For an array, it has to be homogeneous elements. Here, this is a number, this is character, this is another number. But in array, it has to be homogeneous elements. That means if you define an array like this, okay, let's say if you are defining your array 3 is np.array, if you do the same thing like this, if you do this the same way, 4a6, array 3 will be created. But what type of object is that array 3? Though this is numeric, all of them will be considered as character. This will also be character. This will also be character. Everything else will be character. That means if you print array 3, if you print array 3, to your surprise, what you will find is 4 is in quotation, 6 is in quotation. What do you mean by when something is in quotes? It's considered as a string. These are all strings. 4 is a string, 6 is a string. For us, it's a number, numerical value. That is not true in the case of list. Let's say if you are trying to print list 3, if you're trying to print list 3, what will happen? 4, not in quotations. Here 4 is, that means this is numeric character. Whereas this is string, which is character. Array elements have to be homogeneous. Everything has to be homogeneous in an array. Okay. Array is not always one dimension. It can be 2-dimensional, 3-dimensional, 4-dimensional, n-dimensional also. Let us see arrays of more dimensions. Okay. Let's say, let us define a 2-dimensional array. Okay. Let me define an array A, which is np.array, the same function. In that, if you give the first list, comma, second list, now that will be a 2-dimensional array. It will be a 2-dimensional array. First list of 1, 2, 3 in the first dimension. Second list of 4, 5, 6 in the second dimension. Okay. This is an array of 2 dimensions. np.array. This is giving me an error. Why is it giving me an error? I have just given 2 lists. I did not bind them. To make this accurate, what you need to do is I have to put them in another list. Look at this. You have to put them inside another list. This will work. Okay. This is an array. A is an array now. It's a 2-dimensional array. If you try to print, what is 2-dimensional array called? It's a matrix, isn't it? 2-dimensional array is a matrix. 1, 2, 3 are the first 3 elements. 4, 5, 6 are the second 3 elements. Okay. The same 2-dimensional array, right now it has 2 rows and 3 columns. How do I make it 3 rows? I simply copy it, and then this is the third row that I'm adding. In the third row, I'm saying 9, 5, 8. This is the third row. So can you make a guess what will be the output? It will be 1, 2, 3, 4, 5, 6, 9, 5, 8. That will be the output of print A if you try to print it. Look at that. Fourth row, fifth row. If I want to add a column, that means I have to say 1, 2, 3, 4. That's the fourth column. And then that's the fourth column value. And this is the fourth column value. 4 columns and 3 rows. 2-dimensional array. How do you get the shape of an array? How do you extract only one dimension of array? How do you find out the important critical information about an n-dimensional array, or across every dimension, how many elements are there? In this, there are 4 columns. In this 2-dimensional array, there are 3 rows. How do you get to know that? Using shape. Okay. You can say my array A is my array dot shape. If you say shape, what will you get in the output? Array dot shape. Here 3, 4. Here array dot shape gave me 3, 4. What does that mean? There are 3. It's a 2-dimensional array. First of all, it has 3 rows and 4 columns. It has 3 rows and 4 columns. Let us go to this array. There is something called income array that we have created. You remember that? So if I say income dot shape, can you make a guess what will be the output? How many rows are there? How many columns are there? There are no columns. There are only rows in that. So income array 6, comma nothing. That means it is just 1-dimensional array with 6 elements in it. That's it. Okay. A dot shape. Shape will give you how many elements are there. There is one more parameter called array dot size. Looking at the output, tell me what does this size do? I told arrays dot size is 12. So first, when I said array dot shape, so let's delete this, or let me put it here once again. Let me bring that down. So array dot shape is 3 comma 4. A dot shape is 3 comma 4. But a dot size is 12. Now you got it. What exactly is a dot size? Size of array means it doesn't matter whether they are in rows or columns. 3 plus 3 plus 3. There are the size of array. Overall, there are 12 elements in that array. Simple. There are 12 elements in that array. Okay. The next one, there is another option called array dot endim, number of dimensions. This you must understand. How many dimensions are there in this array? In this array, how many dimensions are there? There are rows, there are columns. How many dimensions are there? Endim, number of dimensions are 2. If you say income dot endim, number of dimensions in income array, how many dimensions are there in this income? How many are there? There is only one dimension in income. Okay. That is how you create and work with arrays. Any idea, anybody? How do you work with arrays? How do you create arrays? Let's do one thing. Let's do our first lab exercise. Understand the questions here. Create an array, create four numpy arrays with numbers. 4 numpy arrays. Okay. What are those arrays? Like numbers of your choice, whatever your choice is, no problem. Array 0. Zero dimensional array, simple scalar array, simple one element. If there is only one element, that's not an array, simply zero dimensional array. Okay. So understand what is zero dimensional array. Do a little bit of research. One dimensional array, we discussed an example, income or something. Two dimensional array, we discussed an example. Now, three dimensional array, we haven't discussed. Try to give it a shot. What exactly is three dimensional array? So create zero dimension, just a scalar value, one dimension, two dimension, three dimensional array. So try to do a little bit of reading around zero dimensional array. Basically, if you write x equal to 3, that is not an array. Simply, it is zero dimensional array. And then three dimension array also. And then for all those arrays, get the shape, get the size, get endim values, number of dimensions in each of them. That's what I want you to do in our first lab exercise. Make sure that you complete this lab exercise before proceeding further. Let us see how to work with arrays that are created from the data frames. First of all, what is a data frame? Until now, we worked with an array, right? Something which has some elements in it. Usually when you are working on data science projects, you will be working with data sets. What is a data set? Something that has rows and columns, a data table. In SQL terminology, it's called a table, isn't it? You have rows in there, you have columns, you have customer ID, you have customer name, you have customer age, customer income, those values filled there. That is called a data set, or maybe it can be stored in an Excel file, CSV file, or on SQL as well. What we want to do right now is we want to understand how do you handle the data from that data frame if you are getting it into an array. We're going to talk about these data frames a lot later on when we are getting into deep dive into pandas. But as of now, we will just import this data set. To import this data set, you need pandas. Not only to import, sometimes we may have to subset the data. Sometimes we may have to sort the data. Sometimes we may have to merge few data sets. For all these data manipulation tasks, you will be requiring a package called pandas. So we will be getting deep dive into pandas later on. But as of now, let me just get the data using pandas. So how do you get the data? Here the data set name is bankmarket.csv. It has been stored on GitHub. Let us get this data set, store it in the bank. This bank here inside Python is known as data frame. It is known as pandas data frame. What is a data frame? Something like a data set or something like a data table, something that has rows and columns, that's known as data frame. Okay. From this data frame, we take some data, we keep it an array, then we can do some manipulations later on this data frame. First, let us get this data frame into Python. That's our first task. So the data frame or the data set that is there on the GitHub, I have given you the link. You'll be able to access that link. Otherwise, you can take it from this PPT as well. So you can copy paste that link. Okay. So let us give it a name first of all. Let's call this as arrays from data frames. Arrays from data frames. Okay. Import pandas as PD. Pandas is the package that is used for importing the data frames. We are not really getting deep dive into pandas in this session, but later on there is a dedicated session for pandas. There we will get into it. Okay. So we have imported this data. If you want to have a quick look at this data, you can just simply print that data, and then you will have customer number, customer age, customer job, customer marital status, education, whether the customer was defaulted previously or not, what is the bank balance, whether he has a housing loan, whether his contact number is known or unknown. Typical bank details of a customer is what we got from a bank data set. Or if you just want to get the details of the columns and the missing values, etc., you can simply say bank.info. What it'll do is it'll just simply print all the columns along with the number of non-null values. What type of variable is that? Here, integer means a numeric value. Object means a string object. Job, marital status, education. These are all strings or string objects. Okay. Now let us take one column out of this. Okay. There is a column called age. Let's get that one column out of this particular data frame. Let me call that as age variable. Age variable is numpy dot array, and then from that bank data frame, I would like to get only age. You can write it this way. Okay. And whatever is the variable name. So here the variable name is age. You write it that way. Then age variable is created. And what type of variable? This is going to be, obviously we have written numpy dot array. And if you simply say what is the type of this variable, that will be n-dimensional array for sure. N-dimensional array. What is the shape of this variable? Is it one-dimensional array? Of course it is one-dimensional array. And how many rows are there? What is the shape of this variable? It has 45,211 rows, which is the case. 45,211 rows in that data frame. There are 18 columns. Out of that, we are working with one column. Remember, this is one-dimensional array. That's why you will have comma, nothing. There are no columns. This is just one array, single dimension array. If you want to have columns, you may have to get two columns like age, and let's say let us also get bank balance. If I get those two columns, let's say if I'm getting two variables, okay, two variables, if I'm getting, what will be the case? You take the same code np.array, but apart from age, you also get bank balance. By the way, this is a list. Directly, if you give this list, it won't work. You also try to access it. You have to give one extra parenthesis. Otherwise, it will not work because a list of columns you have to give. So that list, if I say two columns list, two calls list is equal to, these are the two columns. And here you can mention those two columns list. Okay. That means if you just mention two columns list, that won't work. You have to give these extra braces as well, so that you will be able to access those two columns list from the bank data. So the two variables is going to be an array. Now, if you try to print that array, two variables array, it will look like this: age, bank balance, age, bank balance, age, bank balance. Then if you say two variables dot shape, now that is two-dimensional for sure. These many rows, two columns only. And if you say this dot size, that will be 45,211 into 2, whatever is that, roughly around 90,000 something will be the value. Size is what? Size is simply overall number of elements. All the number of elements is nothing but the size. Okay. Now, as usual, indexing and slicing is the next important topic that we need to discuss in arrays. How do you index the arrays? How do you access a particular element? How do you slice? What do you mean by slicing? Taking a slice of this data, taking particular values from this data. Let us see that how it can be achieved, the indexing and slicing. How do you access only first 10 elements from this array? How do you access, last few elements from this array? How do you access elements at the indices 1, 9, 10? Only from that particular places, how do you access them? Let us look at that. So first of all, we have the age variable. Where is that age variable? Age variable. Here you go, which is an array. Now, what if I want to access the first element? You must know the answer. How do you access the first element? Simple. First element. Second element of the array. How do you access that? Indexation starts with 0. How do you access the first 10 elements? How do you access the first 10 elements? That's a slice. So 1 to first 10 elements, 0 to 10. And obviously the 10th one will be ignored. It will be 0, 1, 2, 3, and so on until 9. That will be first 10 elements. First 10 elements of the array. Negative indexing. Do you remember the negative indexing? How does the negative indexing work? Let's say if I take this age variable, if I put age variable -1, negative indexing. Do you know how negative indexing work? Do you remember it from our previous session? -1, last from the beginning, like from the end. What is the last one? 37. If I put -2 here, negative indexing starts with -1. -2 is 57. Like even again, you can do slicing and negative indexing as well if you are interested in last few elements. If you want to get specific values in that array, let's say in this age variable, I'm interested in the second element, fourth element, sixth element, second, fourth, sixth element. How do I write that? I write it this way. I'm interested in the second element. I'm interested in the fourth element, sixth element. By the way, second element index is not 2. Second element index is 1. Fourth element index is 5. Sixth element index is Fourth element index is, fourth element index is 3. Sixth element index is 5. I have to give it this way. But to put all of them together, I need to put them in a list. This is a small thing that we need to be aware of. Okay. If you directly give it this way, 1, 3, 5, it won't work. It doesn't work. Too many indices. You can give only one index at a time. But if you want to put all of them as a list, then if you supply a list of indices, then this will definitely work. Once again, if you have only one index, then it will work. But if you have a couple of indices, if you want to get all the values associated with those in one shot, then you must put them inside a list. So you can do it in two ways. Let's say my indices, okay, my index, okay, my index values are these, okay, then you put it here. So this is the exact meaning of what we were doing. Either you do it this way, or the same thing can be achieved instead of my index being written like that. So you simply say, instead of that, you simply take here in the place of my index, put that index. That's the reason why there are, this is for list, this one is for list, this one is for accessing. Okay. That is how indexing and slicing works. Let us do a deep dive of indexing and slicing. What happens if we take this two-dimensional array? Where is a two-dimensional array? This is two-dimensional array. Two vars is our two-dimensional array. How do you access only first row from here? How do you access only first column from here, or first rows first column, or first rows or fifth row second column? Or if you want to slice it in one-dimensional or two-dimensional manner, how do you do that? The concept is simple, but initially it may look a little confusing. We just need to get used to it. So these are our two variables. First one is age of the customer. Second one is balance of the customer. If I want to access 58, which happens to be first rows, first column, or first columns, first row. So how do you access that? You write two vars. whatever is a variable name, 2vars, by the way, 2vars is equal to, or 2vars. In that, you give those two indices. What is my first index? 0. The row index is 0, the column index is 0. So what's the expected output? 58. What if I write those 2vars? What if I write 2vars, but the 0th row, which is like first row, and 1, the index is 1 in terms of columns. That means this will be printed 2143. Usually if you write it twice like this, what happens is if you're not using print option, the first one will be ignored anyway. It will be calculated, it will not be printed. Automatically the output of second one will be printed. Maybe to avoid confusion, I'll just put it in a second. Okay, here. What if you want to print the second row, first column? Second row, first column. Like again, 2vars. Again, you write the same thing. 2vars. Second row, the index is 1 for second row, and the first column is 0. Here you go. 44 is printed. That's how you print it. What if you want to print first two rows? What if you want to print first two rows and one column? Okay. If you want to print first two rows of this column or this column. First of all, first two rows. What do you mean by first two rows? 0 to 2. And which column do you want? Column 0 or column 1? That means is it age or is it balance? I'm interested in age. Then here you go. 58, 44. Otherwise, if I'm interested in balance, I write the same way. If I'm interested in balance, first two rows, which is like 0 to 2, that is the first two rows. First two rows. Which column you want? I want column ID1. Column ID1 means second column. Index is 1. 2143, 29. Got it? This is for rows. This is for column. Does the negative indexing work here as well? Can you make a guess? What is the output if I put 2vars minus 1? 2vars minus 1 is same as 2vars 0 from the beginning. Minus 1 is from the end. If you just simply put it that way, you will get the output as 37, 2971. 37, 2971. Expected, isn't it? What if you want to do the other way around? Let's say similar to that. Let's say the last row, but first column or two columns. Like you can work with negative index as well. But maybe later on when you reach to the advanced level, then you can work with negative index. Maybe initially you get clarity on that positive index starting from 0. You can also index everything from the back as well. Okay. Let's say if I write 2vars, and then the first one, I keep it as minus 1. That means I'm talking about this one. And then I put 0 to 2. Let's say minus 1, comma 0 to 2. That means I'm talking about the last row, but two columns. That means 37, 2971 will be printed. So this is pretty much same as this one here because there are only two columns. You don't need to specifically mention 0 to 2. Or if you would have mentioned this way, 2vars and then 0 to 1 or simply 1, then you will get only 2971. If you would have mentioned 0, then you will get 37 only. Okay. That is the negative index part. Okay. There is another thing called if you say 2vars and then if you want to take all the rows, that means from the beginning row to the end of the row. Then you simply say, let's say first one will is for rows, this is for rows, this is for columns. In here, you put from beginning to the ending. So simply you don't need B and E, simply you just put it this way, beginning to the ending. So if you don't mention anything, that is from the beginning. If you don't mention anything, that is from the, so all the rows. And which column do you want? All the rows, and I want the 0th column, which means simply it will print everything from the age variable. So look at that. Everything from the age is printed. The same code, if I rewrite it this way, all the rows, again, 2vars, So from here, I want all the rows and column number or column ID 1. That means I want balance. Okay. Then I simply put it that way. I'll get the balance. This colon means beginning to the ending. What if I ask you this question? I want all the columns. All the columns are required, but only 2 rows. That means I want 58, 2143, 44, comma 29. Only 2 rows, but all the columns. So again, you write the array name. 2 bars is my array. I want all the columns, right? Go to the columns place. This means all the columns. How many rows you want? Which row you want? I want, maybe I'm interested in only first row. Okay, that is the first row. You got it. 58, comma 2143. Do you want the second row? Here you go. Second row is in front of you. You want first 5 rows, all the columns, but first 5 rows, that is also possible. 0 to 5 is for rows and columns is all the columns. 0 to 5 rows, all the columns. So these syntax, if you see, that may be a little confusing, but the meaning behind them, understanding them is not that difficult. You just need to practice. That's it. Only practice. Once you practice all this, you will be able to easily understand what is happening with indices. Maybe for now, ignore the negative index, practice all the positive index side. Okay. You can also take something called Boolean index. For example, if you take the age variable, what is our age variable? One-dimensional array, right? Age variable is equal to np.array. We have defined it, but I'm again defining it just for the sake of clarity. Bank data set age. This is our one-dimensional array, which is like every customer's age. Let's say, let's create a condition. What is my condition? My condition is age variable. Age is less than 50. Well, that's my condition. Age must be less than 50. That's the condition. By the way, what type of variable is that condition? Do you remember? Boolean it must be, isn't it? What type of variable is that? Boolean. Condition is n-dimensional array, but the values inside that condition, that will be Boolean, isn't it? Condition. What are the values does it take? True, false, true, false, true, false, and all that. The type is, it's an array, but it's a collection of all the Boolean values. Boolean value, true, false, true, false, true, false. Everything is true, false. Do you remember Boolean? That was one of the type of data that we have discussed in the last session, Boolean session. Okay. Apart from the other dictionaries, lists, the numbers, strings, we have discussed Booleans as well at that time. So this is the Boolean variable. Condition is an array which contains all the Boolean values. Now what you can do is, instead of writing, let's say age variable, let us suppose if I want to access only every age where it is greater than 50, how do you do that? You simply say, right now, the age variable, let us say if you look at the shape of it, if you look at the shape of it, shape of the age variable, it has 45,000 rows in it. 45,000 rows are there. If you create a new variable, let's say new underscore age variable, what am I trying to do is I'll take the age variable and I'm applying the condition. Do you remember the condition? I'm taking only those guys. What is the condition? Age is less than 50. I'm interested in only those customers whose age is less than 50. That I'm storing in new age variable. 44, 33, 47, 23, 25, there will be no value that will be more than 50 because I'm taking that condition where age is less than 50. Now, if you see the shape of new age, overall age is having 45,000 records. New age dot shape, how many records are there in it? Not all 45,000, only 35,000 records are there. Where are the remaining 10,000 records? They are having age more than 50. Okay, getting it? We are selecting not on index here. We are selecting values based on the condition. Here, the condition here is age must be less than 50. That we stored in a condition. And then we are creating a new array based on this condition. Let us suppose You want to change the condition. I want to select all the customers. Let me create a new condition. Condition 2 or condition 1. This is the new condition that I'm creating. That is age must be greater than 60. These are the customers. This is condition 1 where age is greater than 60. Simply I have created a condition. Okay. Age is not defined. Age is not defined. Age where is defined. Age where is greater than 60. That is a new condition. And what are the values this new condition takes? The same thing. True, false, true, false, true, false. Those are the values that it takes. Some true, some false. Then I'm creating new age variable. Let me call that as new age 1. Okay. Where I'm saying condition 1, where the condition is met. Now, if you take new age 1, there you will see everybody whose age is greater than 60. How many records are there in this new age 1? How many records are there? There will be much, much lesser number of records here, isn't it? Much lesser number. 1118 records are there. What if you want to do the opposite of this condition? What if you want to select everybody who did not meet the condition? Here, everything that is true, 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 true will be selected. What if I want to select all the false values? By default, it is selecting everything which is true. So if you simply write condition 1, it automatically means that this condition, whenever it is true, it this algorithm is taking, or this particular command is taking those values, and the shape of new age is 1118. If you want to do the opposite, that means condition is false. That means when the condition is not met, then all the other records out of 45,000, if you remove those 1,000 records, you will have 44,000. These are the ones. So for true, you don't need to really write it. For false, if you want to take the opposite of it, you can put condition is false. Sometimes you can put exclamatory mark also in some places. But here you can use this method to find out all the customers whose age is less than 60, which is like our condition is not met. If you want to meet our condition, that is condition is true, then you have to do like you have to put double equal to, that is to compare. Usually you put one equal to, that is to assign. But here assignment is not our objective. We want to compare it. Okay. That is on the indexing and slicing in arrays. That brings us to the second lab exercise. What I want you to do is go to this lab exercise and do this on accessing of arrays. Create a two-dimensional array, name it A with shape 3, 4. That means you may have to create something like there are 3 rows, there must be 4 columns in it. Create it and you can name it as A or B. Slice it in such a way that understand this, and then create B. And then in an array A, do this, array B, do this, print the array A again, print the array B again, update this, etc., etc. Try to understand each and every question. Some of them may not have obvious answers. You may have to do a little bit of thinking. You may have to do a little bit of searching on internet to solve this problem, but don't give it up. Try to complete it before getting on to the next part of exercise or the next subtopic within Numpy. Is it possible to create a two-dimensional array with 3 rows and 4 columns, fill all the elements with zeros, or fill all the elements with some random numbers between, let's say, 10 and 100? Is it possible to generate some random array with some distributions? These are known as placeholders. What is a placeholder? I want to create a matrix first and I want to fill all of these values with 5. I want to create a matrix first, fill all the values with zeros. Later on in the programming, I'm going to do some calculations and fill the values later on. But is it possible to create initial placeholders? Yes, it is possible to create initial placeholders. What you need to do is, let's say if you want to create an array with all zeros, if you want to create a matrix with all zeros, you write np dot zeros. That's a function, array related function, np dot zeros. In that, you mention how many rows are there. There are 3 rows, there are 4 columns. I want to create a matrix with 3 rows and 4 columns, np dot zeros. Now here is a matrix with all zeros and ones, okay, or zeros. everything with 3 rows and 4 columns. There are no ones here because np.zeros creates only zeros, 3 rows and 4 columns. Zero dot means like there is nothing after that. You can round it off also. Doesn't matter. We just simply created everything with zeros. Or what if I want to create everything with ones? Is there any function like np.ones? np.ones. Oh yeah, there is a function called np.ones. Is there an np.twos? I don't know. Let me check. Oops, np.twos are not there. np.ones is there. np.zeros, np.ones is there. Nothing else. Okay. You can use something called, let's say, if you want to remove this, you can make it an integer. You can say my data type, D type. Like if you really are strict that I want to have, no decimal values, one dot something, 1.0 or 2.0. If I don't want it, like say data type is np dot integer. I want to create everything with integer int 16 or something like that. Okay, if you put it that way, everything will be an integer. Okay, but for zero it doesn't make any sense, but like you can also put it there also to make it like slightly look neat. That also can be done. Okay, np.zeros, np dot, what is the use of it? Maybe at later point of time, sometimes you may have to create blank placeholders and you will be editing those values of those blank placeholders later on. Okay, when you're doing the programming. Okay, if you want to create some random numbers, let us suppose if I want to generate two random numbers between 10 and 30, then you say np dot arrange 10 comma 30 comma 2. What is this code doing? np dot arrange, arrange. Yeah, that should work. Let us see what is the issue. Numpy dot arrange. Did I write any spelling mistake? arrange, arrange 10 comma 30 comma 2. Numpy has no attribute called arrange. Oops, it is not arrange. I think that is the mistake that I have done. Come here. It is not arrange. Make a note here. Even I missed it. It's not arrange. It's a range. np dot a range. It's good that we made a mistake here so that we can remember it later on also. Okay. So np dot a range. So what is it doing? Between 10 to 30, it is creating all the random numbers, but with a particular gap in between them: 10, 12, 14, 16, 18, 20, 22, 24, 28. So what is the gap in between them? 2. What if the gap has to be 3? This one. Usually the code that I have seen a lot of people doing is np.a range, and that is it. That's the thing that I have seen people doing it. A lot of times while writing the code, simply people do this like 0, comma 100, np.a range 0, comma 100. That's it. And these numbers will be used somewhere later on or in some code or somewhere these numbers will be used. If you don't give any number, by default, it will be taking the range or taking that interval as 1. Can you make a guess what will be the output for this one, comma 10? What will be the output for this one? If you want to do the documentation of this, use the control tab and then control option. And once you execute this and then bring the control, then you will get to know what are the options in this. Okay. Or while you're typing, sometimes you will tend to get those. It's loading. It is slightly slower. This is the NP. And then within a range, come to that a range and then try to hold control, then a range built-in function in, and this is the only documentation that we have about a range. And then if you put 10 comma 100 comma 10, that means between 10 to 100 with a interval of 10, the numbers will be printed. Okay, that is a range. There is a slightly similar function but does a different job. There is something called line space, np dot line space. Let us see what does that do. Line space. If I say 10 comma 30 comma 2, what it gives is, earlier it was A range, what it used to do was with a gap of 2, it used to give all the numbers. But what it will do is this particular one, it will exactly give two values and with line, what is that? Line space. Again, I made a mistake. It's not line space, it is lin space. That was A range. This is lin space. Okay. 10 comma 30 with a space here. Earlier the interval was 2, but here we want to generate two elements between 10 comma 30. So what does this lin space do? It will simply divide the interval from 10 to 30 into two parts. Okay. Or if I want to divide it into 5 parts, then what will be the numbers that you will get? On that line, you have to imagine a line from 10 to 30. Then the points on that line, 5 points on that line will be 10, comma, 15, comma, 20, comma, 25, comma, 30. These are the 5 points on that line which are equidistant. Okay. Earlier, these are the 2 points on that line. 2 points doesn't make any sense. The first point will be 10, last point will be 30. But this makes sense, 5 points. If I want to break it into 10 points, so it will be 10, comma, 12.22, comma, and then this one, finally 30. Okay. These are the 10 points. I think 9 points might make sense between 10 to 30. Yeah, 10, comma, 12.5, etc., etc. Let's say 0 to 30 if I'm making 10 spaces. Okay. 0 to 30 if I'm breaking it into 10 parts. How does that look like? 0, 3.3. Let me make it like 1 to 30. Then it will be like 1, comma, 4.22, etc., etc., until 30. So what exactly this does? Okay. What is it doing is, let's say if you are taking the initial number from the last number, if you take that as a line, okay, a line whose starting point is 0, or line whose ending point is 30, and if you are taking 10 points on that line, these will be those 10 points which are equidistant. 0 to 3.33 is same as from 6.67, etc., etc. These are all having exactly equal distance. Okay. Let's say if you are saying 0 to 40, if you are breaking it into 10 points, these are the points that you will find on that line, including 0, including 40. Those are just initial placeholders. You may not require this A range or lin space everywhere, but I have seen a lot of people using np dot zeros and np dot one. Np dot ones, a lot of people don't use it. Np dot zeros is the one that is used as an initial placeholder. Then some places I have seen people using np dot a range to generate the numbers in a sequential manner. That lin space is very rare. If required, you can use it as well. Now let us see how to generate random numbers in Numpy. Earlier, we were creating numbers in a particular range or in a particular order. What if you want to generate some random numbers, some 30 random numbers I want to create, or some random numbers which are distributed normally, or distributed like there are something called statistical distribution. That means the numbers are arranged in a particular order. If you want to generate them, then you have to use a function called random. np dot random dot random. Okay. np dot np is a package, random is a function. In that there is a function called random. If you use that, so this is a package, sub package, this is a function that will generate one random number randomly. This is one random number. If you say 30, 30 random numbers will be generated randomly. These are randomly 30 numbers that are generated. Now, instead of randomly, if you want to mention a particular distribution, there is something called distribution, statistical distribution. So if you want to get uniform, okay, np is the package, random is the sub package, uniform is the function. Generate 30 random numbers using uniform distribution. Okay, so here you have to mention size parameter, size equal to 30. Then you will get 30 random numbers that are generated uniformly. Uniform distribution means the probability of getting any value is same between 0 and 1. You will get any value. Like this is called a particular distribution. Instead of generating randomly, we are generating using this particular distribution. There is something called normal distribution. We can generate 30 values in normal distribution as well. These are like around zero, these numbers are generated. But this normal distribution, uniform distribution, based on the need, you can use them. Maybe once you understand what is uniform distribution, once you understand normal distribution, then you may need them. But in general, the most frequently used random number generation one is np dot random dot np dot random function. And this random function can create 30 values or 20 values, or you can also create random values in a matrix format, two-dimensional array also. I want to have a matrix of 4 cross 4 randomly created values. This is a 4 cross 4 randomly created values, or 2 cross 4 randomly created values. That is also possible. Can you also reshape it? The shape is, let's say, first you have created a size of 30. Okay. 30 random numbers you have created. Okay. Yes, I have created 30 random numbers. Now this is single dimensional array. Can you make it these 30 random numbers into 6 rows and 5 columns? Can you reshape it? Right now, this is unidimensional array. Okay. Or let's say, let's talk simple words. Let's say 10 random numbers. These are all one dimensional array. What if I want to have 5 rows and 2 columns? What if I want to have 5 rows and 2 columns? Can you reshape it? Yes. You need to store it in an array. Let's say my array name is A. Now the shape of this array, if you see A dot shape, first of all, we have to execute this. A is this one. A dot shape is how much? 10. It is just an unidimensional array. Can I make it two-dimensional? Of course you can. A dot reshape, reshape, A dot reshape. And which reshape you want to have? I want to have 5 rows and 2 columns. Is that going to work? Yes, I have made it into 5 rows and 2 columns. By the way, you are not assigning back to A. If you don't assign it back to A, it will not really change A. A is still the same array. A is still the same array. Here, if you reshape and if you assign it back to A, now you have updated A. Now what will happen if you try to print A? It is having 5 rows and 2 columns. That's the shape. You can use the reshape option to reshape. Let's say if you are generating 30 random numbers, or if you're generating 12 random numbers. Let us take another example. What if I'm generating 16 random numbers? This is the 16 random numbers. That is the shape of A. Let's print A, those 16 random numbers. These are the 16 random numbers that I have. What if I want to reshape it into 4 cross 4? Is it possible? Yes, it is possible. 4 cross 4. And then this is the new simple 1 2 3 4 values are taken, kept it in the first row, and then 1 2 3 4 values are taken, next 4 values, kept it in the second row, third row, fourth row, like the when last value is here. Reshape. Okay. Reshape, when you really want to change the variable or the array itself, you have to assign it back to that array. Can you reshape it into a three-dimensional array? Let us suppose if you have a randomly generated array with 30 elements in it. What if instead of making 6 by 5, I want to make it like 2 rows, 3 columns, and then 5 is the depth. If I want to make it like A as in a different reshape, let's say A dot reshape a three-dimensional array. Three-dimensional array, 2 rows, 3 columns, and 5 elements in each of them in the depth kind of thing. So there will be like, this is the option that you are getting. It will be slightly difficult to understand what is happening. So let us take lesser number of elements, 10 elements, 2 rows, and let's say 12. 2 rows, 2 columns, 2 twos are 4, 4 threes are 12. If you do it this way, let's first create that and then reshape it. Look at this. There are 12 elements. They are arranged in this manner. There are two rows. This is row number 1. This is row number 2. Row number 1, because it is a three-dimensional array, we have to arrange it somehow. Row number 2. And then there are two columns. Okay. Which one is column number 1? Which is column number 2? Let us see column number 1 and column number 2. And then in each column you have like three elements in it. Okay, so this is column 1, column 2. This is column 1, column 2. Can you see that there are overall two rows? This is row 1, row 2. Okay, row 1, row 2. Clear? What is column 1, column 2? This is column 1, column 2. Inside that row, inside the second row, this is column 1, this is column 2. Now, inside each of that, inside each row, each column, that will be a cell. Inside each cell, you have three elements: cell 1, cell 2, cell 1, cell 2, cell 3, cell 4. There are four cells like that. Okay. Yes, you can reshape it into three-dimensional also. It is slightly complicated. You may not require it, but reshaping is possible if you are giving the right size using np.reshape. But can you give wrong dimensions? Let us suppose you have an array of size 12. You can reshape it into, let's say, you can reshape it into 6 by 2, 6 by 2, 6 rows, 2 columns. That will work. 2 by 6 will also work. 2 rows, 6 columns. That will also work. 4 cross 3 will work. 3 cross 4 will work. What won't work is 4 cross 5. That will not work. That will throw an error. You can't reshape because 12 elements, you cannot reshape into 4 cross 5. Even 4 cross 1 also you cannot reshape. Lesser or more you cannot reshape. 4 cross 3 or 3 cross 4 or 6 cross 5, because you gave 12 elements, I can arrange them only in a compatible manner. 6 cross 2, 6 2 is 12, 4 3 is 12, 3 4 is 12, that way. Okay. If you are giving wrong dimensions, it won't work. Okay. What if when you are building this reshaping, if you want, let's say, 4 rows, or let's say you have an array with 100 elements in it. This is an array with 100 elements in it. What I'm interested in is rows only. These are all the 100 elements. In this array, I'm not interested in the columns. I'm interested in rows. I want to take, let's say, out of these 100 elements, I want to say a dot reshape. I want to have 4 rows, and I don't care about my columns. The number of columns, I don't care. You do the mathematics. You do the math. 4 rows I want, and put it like in a compatible manner. 4 rows and how many ever columns you want. So 25 columns. Even if I don't want to give it, simply you put -1. 4 rows and any number of columns. Any number of columns is like -1. So in reshape, if you give this manner, 4 rows, I'm interested in rows, and about columns, I don't care. Let it be whatever is the compatible one. So what Python will do is it automatically, it will find out, yes. So let's say if there are 10, okay, I want 2 rows and columns I don't want to give, you simply put -1 there. It will just do it like, do it this way. 2 rows are given to you and columns are automatically calculated. The same thing goes with rows as well. Let's say you're interested in the columns. Let's say A is of the shape, now A is of the shape 30. 30 elements are there in A. Now if I say what I want is I simply want 10 columns. How many rows are there? I don't want to do any calculation. If you don't want to do any calculation, you just put -1. Any number of rows, but 10 columns. Any number of rows, 10 columns. So you have 10 columns with you. The number of rows will be 1, 2, 3. 3 rows are there. Similarly, let's say any number of rows, what I want is 5 columns. Here is how it will go. 2 rows with 5 columns. I did not give 2. Since I gave -1, the calculation will happen automatically. The unknown dimensions also you can give. Let us suppose, once again, let us take one more example. Let us suppose if you are giving 30 as the number of elements. If you want to make it into 3 dimension, a dot reshape, okay, a dot reshape. I want 6 rows and then 2 columns, or let's say I want 6 rows, 1 column, and the other dimension I don't care, whatever it is. The other dimension I don't care. Then if I leave it, then it will work. 6 rows and 1 column, and what is the other dimension? 5, 5, 5, 5 elements in each of them. Or if I say I want 3 rows, if I want 3 rows, if I want 2 columns, and the other dimension I don't care, then it will arrange accordingly. Similarly, rows I don't care, columns also I don't care, and the other dimension, is that going to work? Is that going to work? No, because this may have multiple options. Let's say if I put -1 comma -1 comma 3, it can be 2 rows 5 columns, or 5 rows 2 columns. This won't work. You have to mention at least 2 dimensions. So if you mention this, the other dimension will be automatically calculated. But if you give 2 parameters for Python to decide, that it will throw an error. No, you can only specify one unknown dimension. You can specify one unknown dimension. Let us suppose, once again, if you have a data of random values, let's say 300 random values are there. What I want to rearrange, or what I want to reshape it as is a dot reshape. Give the compatible ones first of all. Maybe I want 20 rows. Okay. What I want here is 20 rows and 2 columns. 20 rows and 2 columns. The third dimension, I'm not aware of it. You simply put -1. You can't reshape a size of 300, 20 comma 2. 20 comma 2 is 40. Can you divide 300 with 40? Sorry, you cannot. So let us make it like 25 rows and 2 columns. 25 twos are 50. Then the third dimension will be 6. So you can do this now. It has to be compatible. It has to be compatible. Got it? That is how you can reshape the arrays, even if you do not have any idea on the dimension of the third or the second dimension, you will still be able to reshape it. Let us suppose we have this array right now. If you store all this in B right now, array B is of the shape. What is the shape of array B? Let us see the shape of array B. B dot shape. Now it is of the shape 25 by 2 by 6. What if you want to make it into a single array? If you don't want to have it, let's say if you reshape it into a matrix, let's say right now 300 elements are there, 25 minus 1. If I keep it, then what is the shape of B? 25 by 12. I don't want B to have 25 by 12 shape. I want it to have unidimensional, one-dimensional array, 300 elements, not really 25 by 12 elements. Or a simple example would be A has 10 elements, and if I'm keeping it B as 5 cross 2, then B will be 5 cross 2. What if I don't want B to be 5 cross 2? I just want B to be having 10 elements only. Then you can use an option called B dot flatten. Okay. So what does that do? B dot flatten. It'll simply flatten that array, which means it'll make it unidimensional. It'll be an array. If you just simply reassign it to B, B dot flatten. So now B dot shape will give you what? B dot shape will be having 10 elements. Earlier B dot shape was 5 cross 2. Once again, what are we doing? There are 10 elements. Right now B dot shape, B is of the shape 5 cross 2. B is a matrix now. How do you convert a matrix back into unidimensional array? You simply use the function flatten. Now B will be no more a matrix. It will simply be an array with all unidimensional, one-dimensional array. Earlier it was two-dimensional array. You can use flatten option as well. Now on arrays, you can apply maximum, minimum, those kind of functions as well. Let us suppose if you take our age var, if you remember, what is it? Age of all the customers, age var looks like this. Here only some of the elements, a couple of elements are printed, remaining ones are shown as dot dot dot. It has 45,000 rows. If you want to know the maximum value of this array, you simply write array value dot max function. That will give you, there's no zero here, sorry, array dot max, that you will get the maximum value. Okay, you can also use min function, array dot min function can also be used. If you want to know the average, this you may be able to guess what is the average value of that array, mean function can be used. If you want to calculate the standard deviation, what is standard deviation, that we can see later. Okay, there is a measure called standard deviation that will give us an idea on what is the average deviation of the value from the mean. What is on an average, what is the deviation from mean, every value, how much is average deviated. So 40 is the mean value. Every number on an average is deviating 10 points. Some points will be deviating more than 10, some points will be deviating less than 10. On an average, every point, every customer is deviating 10 points from the mean on an average. So these are some of the functions that you can use for calculating the minimum and maximum, mean, etc. Okay. So within this value, let's say within this array, what is the maximum one? 95 is the maximum value. Let us take first 10 elements of this age variable. Let me call that as age subset. Okay, age subset. Age subset is first 10 values, 0 to 10. So what will be that age subset consisting of? It consists of 10 values. Okay. Now what if I want to know the maximum of this one? Age subset maximum value. What is the maximum value of age subset? Out of these 10 customers, who's the maximum? 58. What is the other way of knowing it? Age subset dot, what is the other way? Max. That also works. Age subset dot max. 58 is the maximum value. Now, what if I want to know where exactly, which customer, let's say this is customer ID 1, customer ID 2, which customer ID has this 58 in it? How do I know that? Which customer ID? So what I want to know is maximum value of age is 58, but when is it occurring? Is it index 0? Is it index 1? Is it index 2? Is it index 3? Which index? When is the first time it is occurring? Which index where 58 is occurring? If you want to know that, you can use an option called argmax. So you use age subset, then argmax. And if you do that, what it will give you is an option 58 is occurring in the 0th index. Though it is occurring twice, first instance, whenever it is appearing for the first time, that will be given to you. Okay. Let us suppose if you take first 100 elements, that will be that age subset. If you take the maximum value of those first 100, that is 60. Whenever 60 is occurring for the first time, 60 is occurring for the first time, when is it occurring? In which ID? 18. If you go to that ID 18, automatically it will be displayed to you. 18. Where is that 68? Where is 68? At the 18th position. 1, 2, 3, 4, 5, and so on, so on, so on. 58, 41. So the 60 is appearing here. 60 is the maximum value, and it is appearing here, 60 in the 18th position. Similarly, you have minimum value. You can calculate for this subset. You can calculate minimum value. Minimum value of this age is 24. When is it appearing for the first time? Argmin. Argmin, what does it do? First time, when is this 24 appearing? 24 appearing in the 54th position. If you keep on looking for 24, 24, 24, this is the position that appeared for the first time. That happens to be the 54th position, ID 54. Or to make it simple, if you take the first 10 elements, and calculate the minimum value. That minimum value happens to be 28. And which position 28 appearing for the first time? Which position is that? Whatever is the position 6, ID 6. That's the first time that it is appearing. That is known as argmax, argmin. Max and min will tell you what are the actual maximum and maximum minimum values, but argmax and argmin will tell you which is the ID where the maximum value is present, which is the ID where the minimum value is present. Sometimes you may want to find out the maximum and minimum value, their IDs, not exactly where they, what are the values there, which position they are appearing. That's what you may want to know. In that situation you can use it, and the same thing is true even in a two-dimensional array as well. Okay, for example, if I'm creating a random array, let's say, let's create a random array of 12 values, but two-dimensional this time we'll take. So this is a random array which is two-dimensional, 12 comma, let's say 4 comma 5, 4 rows and 5 columns. Np dot random. Okay, we had to reshape it first. Let us create 4 5 20 elements and then reshape it. That would be better. Then a is equal to a dot reshape with 4 rows and 5 columns. That's the way to go about it. And if you try to print a, that's a matrix of 4 rows and 5 columns. Now what I want to do is in every column or in every row, where is the maximum value? Let's say in this particular row, I want to know where is the maximum value. This is 0.88, this is 0.71, this is 0.34, this is 0.190. This is the maximum value index. Now, I don't want to get the maximum value out of it. I want to get the index where the maximum value is. If you want to get the maximum value, that is simple. A dot max. Then if you say x is equal to 0 or x is equal to 1. Let's say if you say x is equal to 1, then what will you get? In every row, okay, in every row, what's the maximum value? This is the maximum value. This is the maximum value here. Second one, where is the maximum value? This is the maximum value. This is the maximum value. In every row, what is the maximum value? That's what you will get. In every row, what's the maximum value? If you want to know in every column what is the maximum value, you put it as 0. In every column, the maximum value is in the first column, the maximum value is this much. In the second column, the maximum value is this much. Third column, column by column, maximum values, row by row, maximum values. Okay, that's what you will get. Okay, in a particular axis. But I'm not interested in max. I'm interested in argmax. If you say argmax, so fourth position, first position, index 4, index 1, index 4, index 1. Let's say if I'm then generating some other here in the second ID, ID2, again ID2, again ID0, then ID2. These are the positions where you have maximum values. Similarly, argmin, if you do it, argmin, minimum values are present at position 3, position 3, position 3, position 1. Now, what if I want to see row by row manner? Like in this, here we have seen like in a row, which column has a maximum. Let's say in a column, which row has max or which row has min. If you want to see this column versus this column versus this column, column by column in this column, first you want to take the column, then you try to do, let's say first we will try to see the max and minimum values in each column. Let's first calculate max values in axis 0. So what will you get? What will you get? Let's see the output. The minimum values in or maximum values in each column. In this column, the maximum value happens to be this one. In the next column, the maximum value happens to be this one. Next column is this one. Next column is this one. Next column is this one. Similarly, you can calculate minimum. But what if I put argmax? Then if I put x equal to 0 in ID2, then ID1, then ID3, ID3, ID3. What is ID3? This is ID3, this is ID3, and then again ID3. Are you getting? Max versus argmax. What is max? What is the actual maximum value? But what is argmax? The position or the index at which the maximum or minimum is residing. That's what argmax will do. That will bring us to the next or the last lab exercise in NumPy. What are we going to do? We are going to create a 1D array of 50 values between 0 to 1, which are equidistant. You have to use a range, not a range, and then reshape it, generate some random numbers, look at the max min values, and look at the max min values in each column and the indices as well. This particular exercise will give you an idea on how to handle arrays. NumPy is one of the important package when you're working with Python. You may not require to learn all these commands that are discussed in this session. At least first 50% of it, if you understand, then it will be very, very useful. There are other commands as well based on the need. You can explore them, but right now you can practice these, and there will be some other exercises as well that will be posted later on. But as of now, try to completely watch these videos. If some of them are confusing, try to watch them 2-3 times and make sure that you do all these lab exercises. Then we are going to get into next package within Python. I'll see you in the next session.